In this section, we're going to talk about numerical dispersion, or in other words, is there a number that I can use that's going to determine or tell me how spread out the data are, or in other words, how dispersed the data are. The first term you should recognize, it's called the range, and the range is really just a basic way for us to say that what the range of the numbers are. We find it by taking just the difference between the largest and the smallest data values. So we're getting a sense for that range of numbers ranging from the smallest all the way up to the largest data value. The next term we need to understand is called standard deviation. Now, standard deviation is defined as the average distance from the mean. And I'm going to illustrate what that means in the next slide. But first, we want to discuss standard deviation's symbols. So just like in the mean, we have two symbols for population and sample. In standard deviation, the sigma symbol that I've drawn the arrow to here looks kind of like a cursive O, if you will. But anyway, the sigma symbol is going to represent population standard deviation, whereas lowercase s is going to be the symbol we use for sample standard deviation. And again, standard deviation we're defining is just that average distance from the mean. The third and final type of numerical dispersion is variance. Notice that variance is really just the square of our standard deviation, so we're going to use the same symbols, we're just putting them with a square symbol at the top. So now let's illustrate what we really mean when we're talking about standard deviation. I'm going to put up here a scatter plot and make it a little bigger, and I'm going to put up here dots. Each of these dots are just representing some data for whatever I might be thinking about. We learned in the previous section that the average of all of my data is going to be considered the mean. And so here I'm going to draw a line, and I'm going to let that line represent the mean, which we said was either x bar or mu. So I have a single value here that's the mean, that's the average of all of these data points that you see on the screen. And what we're going to think about here is if I wanted to go in and let's say that I want to measure how far is, let's circle this point here, how far is that away from the center? So if I took the difference between the mean and my data point, my individual data point, I would get some positive value because my data point is going to be above the mean. Then I can come in and I can measure maybe another point. We'll see that that is going to be a positive distance away from the center or away from the mean. I could even measure this point here that's below the mean. So I measure the distance and it would be a negative value because it's below. And I can keep measuring the distance for every single point here on my scatter plot. And if I were to add all of these values up, all of these distances up, the positive and negative values, and then divide by all of my data points, that's going to give me the average distance away from the center. So we want to think about our standard deviation as this distance that we're just really taking the average of, just like we do when we think about the mean. Now, the formulas for standard deviation and variance are here on the screen. Notice that, again, we have our population and our sample standard deviations and variance given. Let me take just a moment also to explain to you what these formulas are telling us. So here, I'll just take our population standard deviation, and let's discuss this x sub I. So x sub I is each of the data points that I had down here in the screen. So I have data point 1, data point 2, data point 3, data point 4, and so on. So x is our data, and the I is just incrementing the data for however many we might have. Now, you already know that mu here stands for our population mean. So just like I was explaining, we're going to take the difference between the data point x sub I and the mean mu, and then we're going to end up squaring it in this formula, and then the next thing we're going to do in this process is we're going to sum them. So that capital E, it kind of looks like an E right there, is a capital letter sigma, and it tells us that we are going to sum whatever I'm looking at. And then finally, once we've added everything up, we're going to divide by the total number that we have. Remember, capital N stands for our population size, and lowercase n is going to be sample size. So just like we do when we take the average, when we think about our mean values, where we add everything up and divide by the total, that's technically what we're doing here. And then once we've completed all of those steps, we're going to end up taking the square root of the entire process. So that's the idea behind the formula for standard deviation. And then you'll notice that here for variance, variance is really just everything that was underneath the square root symbol from standard deviation. And that is because when I take the square root of a squared number, I get back the individual value. So we have our two formulas here for standard deviation and variance. And then you'll notice one other thing, that between my population and sample formulas for each of these two, standard deviation and variance, they vary just slightly. They're varying by the mean that we're going to be looking at. So here I have population mean, population size. Whereas in the sample standard deviation, I have sample standard deviation, sample size. So the formulas are very, very close. They are just differing ever so slightly when we try to calculate the standard deviation. Let's look at an example together to be able to determine how we can find the standard deviation by hand. So in this example, I have 6 cell phone bills that were randomly selected from several months, and I want to find those 3 measures of dispersion: the range, the sample variance, and the sample standard deviation by hand first, and then we'll figure out how to do it using StatCrunch. So what you see here are some columns that I've gone ahead and set up. And that's because it's kind of a labor-intensive process to find the standard deviation of a sample set, or the standard deviation of any set, I should say. So here in the very first column, I have all of the cell phone bills. So that would be my sample size, which would be equal to 6. And the very next thing that I need to do from these 6 data points is I need to figure out what is the mean. So my sample mean of all 6 of these values, if I were to add all 6 of those cell phone bills up, divide by 6, I would end up with $41.41. So I'm going to write that right now in each one of these cells here in this second column, 41.41 all the way down, because that's going to help me with this calculation process. The next thing I would do if I was trying to calculate variance as well as sample standard deviation is I need to remember we're going to take the distance from the mean and the data point. Now, don't forget that subtraction is order matters when we're talking about subtraction. So I am going to take my data point and subtract from it the 41.41. So in the first case here, if we take our calculator and we put 35.34 in minus 41.41, we end up with negative 6.07. And to that number, I am going to now square it. And that takes me to the very last cell here. So negative 6.07 is 36.84. Okay, so that's the process that we're going to do. We are going to first subtract each of our cell phone, let me say it in a different way. First, we're going to subtract the average from the cell phone bill. Then we're going to square that number to get the last column. So let's look at one more together. So 4209 minus 4141 is 0.68. And if I square that number, I get 0.36. So using your calculator, I want you to complete the remaining four blanks here. Fill in the rest of this chart and then check your answers with what I'm going to complete in just a moment. Okay, so here you have the finished table. I filled in all of the missing components to the table, and it's the last column that we are looking at now. So this last column here, I want to add all of these numbers up, add all of these 6 numbers together. So in other words, I'm going to sum this last column, and I'll just put parentheses squared because that's what I'm doing. I'm summing this last column here. And when I do that, I end up with 112.92. So all of that work was just to figure out basically the numerator of our variance formula. So let's find the variance first because it is the first step to finding standard deviation. So we would have this variance squared is equal to the sum of x sub I minus x bar squared over n minus 1. Now remember, x sub I minus x bar squared is the very last column here, and when I added all of them together to take the sum, I got 112.92. We're going to divide that by my sample size of 6 minus 1, which is 5. So 112.92 divided by 5 is 2258. So that's our variance. To find the standard deviation, we now need to take the square root of our variance. So we're going to take the square root of 22.58, which gives us $4.75. So our cell phone bills that we have here, the average spread or the average distance away from the mean is going to be by about $4.75. The last thing we were asked to find is the range. Now the range is going to be the largest number in the data set, which ends up being $49.26, minus the smallest cell phone bill, which is $35.34. And we take the difference there and we find out that that's $13.92. So we can find the variance, the standard deviation, as well as the range for this data set by hand. Let's also make sure that we know how to do this using StatCrunch. So here I have the cell phone bills entered into a column in StatCrunch. You can see all 6 of the bills listed here. I want to let StatCrunch calculate for me those 3 measures of dispersion. So we're going to go to Stat, Summary Stats, Columns. This is the same place you went when you were trying to find the mean, median, and mode. Once I hit Columns, I'm going to select the column I want to perform this on, which is the phone column. And then in the center here is where I get to choose which summary statistics I want. We want standard deviation, range, as well as variance. And to select them in the order that I was talking about, I can hold the control button down while I select them. And then I'm going to go to the bottom of the screen, which you can't see, and click Compute. So here are our standard deviations, which is the 4.75 that we calculated by hand. Here's the range, 1392, which we calculated by hand again, and the 2258, again, that we calculated by hand. Now, it's really labor intensive to find standard deviation and variance, and so it will be unlikely that you're going to ever be asked to calculate this by hand, but I want you to understand how it is calculated and what the formulas look like.